All right, we're back with 7.3, similar triangles. So in this section, we're going to be able to discuss whether or not triangles are similar. And it is almost like what we talked about when we were trying to prove that angles were congruent. So in this section, we're going to have three similarity statements. The first one we see here is angle-angle, which says if we know that two angles or one angle is congruent to another angle in the different triangle, and we know that one other one is congruent, that is enough to say that those triangles are similar. They're not exactly not congruent, but they are similar, which means we can use proportional reasoning. So we want to determine whether or not we can figure out whether or not these are similar. So you can see that we have 52, 58, and a missing. So we could just figure out what that missing side is, and if it happens to be 80, then we'll know that those triangles are similar. So if we subtract these two angles from 180, we actually get 80, which is the same as in this triangle, which means this is 58. So if we want to write a similarity statement, we would have to go in the same order. So let's go from small, medium to large angle size. So we'll go triangle, we'll go B, C, A is similar to triangle, and again we're going to start with 42, go to 58, so D, F, E. Determine whether the triangles are similar. If so, write a similarity statement, explain your reasoning. Use what you know about parallel lines. Again, whenever we have parallel lines, we're going to make some assumptions about our alternate interior angles. So these two angles here will be congruent. We also know that these two here are vertical angles, so we can then use our angle-angle statement to make sure, or make a statement that these are actually similar triangles. So we'll start with Q. QXP is similar to NXM. So I want you to press pause and try this one, and then we'll go over it. Okay, so what we'll have to do is figure out this missing one, and if that happens to be 86, then we can make a similarity statement. Turns out this is 86, so that these triangles are congruent. So this is 52 degrees, and again, let's go from smallest to largest. So we'll say triangle BCA is similar to triangle FHG. Okay, so we'll try this next one. It's similar to the one we saw earlier. So we have that these are congruent because they're vertical angles. These are congruent because they're alternate interior angles. So by angle-angle similarity, they are similar. So we'll say triangle WVZ is similar to triangle YVX. So another triangle congruence theorem has to do with the fact that if we know that all of the sides are congruent, or not congruent, but proportional, so you can see that if you were to make a proportion anytime, these here would be similar triangles. So we have this new side similarity, and I don't think this is correct, so I'm going to cross that off. And then the other one is we have a side, we have another side, and the included angle. So that's another thing that we can use for proportional reasoning. So with this next one, we're going to determine whether or not the triangles are similar. If so, write a similarity statement. I want you to press pause and just see if you can identify proportional parts. Okay, so I've identified proportional parts. One thing to notice if you're having a hard time with trying to see which sides are proportional, you can just label them as small, medium, and large, and that will help you to figure out what the corresponding side is on the other triangle. So 4 would be small, 5 would be medium, 6 would be large. So if we go over here, the small side here is 6, the medium side here is 7.5, and the large is 9. So when you do set up your proportions, you can make sure that they are correct, and when I look at my cross products, they are indeed the same, so we can write a similarity statement. So we'll say that triangle, and we'll start with small. So we'll say ACB is similar to triangle. We're starting with D, C, and then E. So when you have triangles like this that are kind of overlapped, I'd suggest like drawing them out so that you have two separate triangles. You can look at their corresponding parts then. So I have a big triangle here, and I have this whole side is going to be 10 plus 15, so that's going to be equaling 25. And this side is going to be 12 plus 18, so that is going to give me 30. So if I want to look at the comparison, I would have to take, for instance, this first side over here and compare that to this side. So we would get a proportion that looks like this, 10 over 25. Is that indeed equivalent to 12, which would be the other side here? Is that equivalent to 30 then? So if we cross multiply in this direction, we're going to get 300. And if we do 25 times 12, we also get 300. So this is indeed proportional. So we can write a similarity statement. I'm going to press pause, see if you can answer that question. Okay, so we have the similarity statement, again, going in the same order. MNP is congruent to MRS. So here we have another one. Again, one strategy would just be to identify maybe the smaller sides. So this side here is the smaller side, and that would be similar to that side. And then this side here would be the medium or large. We don't really know. It looks like it's medium. We don't know the other one. So we'll just go ahead and set up a proportion. So let's check. 2 is to 6 as 4 is to 12. So you just check your cross products. It turns out those are both 24. So we then can make a similarity statement. So you say triangle PQR is similar to, so I started with P, which would mean I should start with S, S, R, T. Okay, so I want you to press pause and try this one on your own. Okay, so check out my work, see if you agree, and they are indeed similar, so we can make a similarity statement. So here's a testing example. So let's say we have RST, and we can just maybe draw something really general here. RST is similar to X, Y, Z, and it says that RS is 2 and XY is 3. Which of the following is sufficient to prove that the triangles are similar? So again, we would need to either apply to angle, side, angle, side, side, or side, side, side. So we only really know that this one side is... Okay, so if we were to, let's say, look at this one, so angle R and angle S, these are in the same triangle, so it's not really going to be helpful. What we really need in this case would be, we don't have any other angles, so that's not an option. Like I said, we don't have any angles at all, so the only option would be to have side, side, side. So my only option is that it would be B. The sides, all three sides would need to be proportional. So let's take a look at this next one. Okay, so in this one, since we have these kind of overlapping triangles, we know that we have one angle, and let's just go through and look. So this one would mean you have that, you know, something about one side. So this would be a side and an angle, and that is not one of our theorems. This says twice the measure, so that's going to be out. This is similar to A. So the reason why we know that this one is going to work is because it is saying A is to C as D is to C, and B is to C as E is to C. So we have this side angle side relationship. So they are similar. just some other theorems that we might see. We saw these before earlier in the year. Reflexive means that you see the same thing on both sides of similarity. So this symmetric here is just where we see the same thing on both sides. We're just flopping them over. So this next one is the transitive property. So if 1, then 2. If 2, then 3. Then 1, then 3. So it's saying that you could eventually put an implied in there for that one. Okay, so we're going to be using parts of similar triangles then to solve problems. Okay, well, I've drawn in some things that we can infer because of the fact that we have the parallel lines going on here. So the magenta and this turquoise color, those are alternate interior, those would be congruent. The green side and the green side in the other triangle will be similar sides, and then the orange side and the orange side will also kind of go together. So we're being asked to find RQ and QT. So if they're similar, we should be able to write a similarity statement, and we do have the green sides, so we could say 4 is to 10, and then we'll go with the orange sides. So you would start with x plus 3 here, and 2x plus 10, and this is a cross product problem, so we would cross multiply. We get 10 parentheses x plus 3 is equal to 4 parentheses 2x plus 10. Distribute here, we get 10x plus 30 is equal to 8x plus 40. I'm going to go ahead and subtract 8x from both sides, so I get 2x over here, and I'm going to subtract 30, so I'm going to get 10 over here, so x itself is equal to 5. Again, remember they're asking us to find the value of RQ and QT. So RQ, which we did know RQ before was x plus 3. So it's going to be 5 plus 3, or 8. And then we were looking for QT. QT is 2x plus 10. So we get 2 times 5 plus 10 equals 20. I'd like you to press pause and try this one on your own. Okay, I've done some markings on here, and we're about to solve for x. I forgot an x down here, so I would subtract 33 from 38.5, and we would get 5.5, and then we would subtract the 77, and we would get 11, and here's an x, so we'd have 11 divided by 5.5, and we get x equals 2. So remember they were asking us to find AC, so we have to go back up and figure out from A to C. That was 3x plus 8. So if we put 2 in there, 3 times 2 gives me 6 plus 8. 6 plus 8 is going to give me 14. So AC is equal to 14. All right, the last few examples, I'm going to skip over them to save some time, but you should try them. And then there's just a summary statement here of the triangle similarity theorems that we talked about earlier.